Hi guys, so in this lecture video, we will be going over a very important and common types of chemical reaction that we cover in general chemistry. And this is the exchange or the double replacement reaction. And again, this is a very important types of chemical reaction. And it normally is the main emphasis in most general chemistry courses. So what happened in an exchange or the double replacement reaction is that when we take solution of two compound or two solution of two compound and we mix them together, then what happens is that they can react by exchanging the ions. And because of it, we call this the exchange reaction. So here's what happened right here. We have two compounds reacting with each other, right? And these are two ionic compounds. So what happened is that the cation of the compound 1 may then combine with the anion of a different compound of the compound 2 to form one product. And now the anion of the first compound is then combined with the cation of the second compound to now form another product. And so let's look at this diagram right here to make sure this description right here is very clear. So we have a first compound. And let's say this first compound right here is the compound AX. And again, it is an ionic compound. And now we have the compound 2. And in this case right here, let's label them as BY. And just like how we would be writing the chemical formula of most ionic substances, the cation is always listed first. So here in AX, the cation is listed first and the anion is listed here. And in the compound 2, B is the cation and Y is the anion. And in the course of this reaction right here, the cation of the first compound is then combined with the anion of the second compound. So A is now binding with Y to form the first product of the product 1, AY. And now B, which is the cation from the second compound, is now bind with X, which is the anion from the first compound. And now that forms the product BX in here. So that's what happened. The cation of the first compound combined with the anion of the second compound. And the anion of the first compound, they combine with the cation from the first compound. So we can also see this as, we refer to this as inner and outer to make sure that you can see this easily. And inner mean the following. When we have the two things on the inner part combined together to form the BX product. And now the outer refer to the combination of A and Y to form this AY product right here. So this is the outer product and this would then be the inner product. But it is important that we're able to follow the charge so we can figure out what the product would be. And again, because A is a cation, it would then bind with the anion Y. And because B is a cation, it would now be binding to the anion X. And therefore producing these two products right here. So overall, that's how we can recognize and predict what will be the products in a double replacement or the exchange reaction. And now, there are two very important considerations that we now need to dig really deep into. First, just because we mix two compounds together, does that always mean that they will react? And the answer, no. Just because we mix substances together, they do not always react. So basically, not all double replacement reaction will take place. But there's only certain types of double replacement reaction that are known to occur. And in order for them to occur, here is the requirement right here. So there will only be a reaction if at least one of the following requirements is met right here. So here are the requirements. First, either the product 1 or the product 2. So the product 1 is AY and the product 2 is BX. So either one of these products is first a precipitate. If either AY or BX is a precipitate, then that's when we will have a chemical reaction. And again, to recall what a precipitate is is basically whenever we have an insoluble solid that fall out of solution. And so if either AY or BX is a precipitate, then now this reaction will occur. And if a reaction were to occur due to the precipitation of one of the product, then this type of reaction is then also renamed or referred to as a precipitation reaction. So that's the first requirement right there. Either the product 1 or 2 is a precipitate. And now, if product 1 or 2 is not a precipitate, it can also be the following. It can be a molecular compound or a molecular substance. Okay, so either product 1 or product 2 is a molecular substance. If either this one of this product right here is a molecular compound, then the reaction would also happen as well. And to make sure that we know how to recognize a molecular compound, when we look at the formula of AY and BX, if either AY or BX were to consist of all non-metal, then that when we know that either AY or BX is a molecular compound. And if either AY or BX is a molecular compound, this type of reaction right here can also be referred to as a molecular compound formation reaction. And third, if we don't have a precipitate and we don't have a molecular substance being produced, then either the product 1 or the product 2 has to be a gas. And a gas, normally this is when we have to know about the physical states of the products to figure out whether it is a gas or not. And so this gas right here would simply bubble out of solution. And if a product being produced is a gas, then this type of reaction right here can also be referred to as a gas formation reaction. Okay, so basically, let's go back to this again. In order for a double replacement reaction to happen, either the product 1 or the product 2 has to be a precipitate or a molecular substance, or third, a gas. So these are the 3 requirements right here. And these 3 requirements are then collectively referred to as the 3 driving forces. So they are the driving force that push this reaction going forward. And DF here stands for driving forces. So if neither a precipitate, a gas formation, or a molecular compound is being produced, so if AY or BX is not one of this, then there will be no reaction. So that's how we know about which types of double replacement would occur. So if we don't have any of the driving forces, then there will be no reaction. So therefore, knowing the physical state and the solubility of the product in an aqueous solution is really important in predicting if the reaction would take place or not. So that's how we would do it. To determine will there be a reaction, we are looking for these 3 driving forces right here. Okay. And now B, the next important consideration. Let's say there is a chemical reaction. Then now, how do we write the correct formula of the product 1 and the product 2? And this is something that we expect students to be able to do. And again, in most of the double replacement reaction that we give in student later, we will not be providing students with the products, but students are expected to be able to write what would be the formulas of the products. And luckily, writing the form of the product is actually really easy. This is something that we have learned and we know how to do already. If we know how to write formula of ionic compound, then we know how to write the formula of the products 1 and the product 2. So the formula of the products 1 and 2 are then based on the charges of the ion to make a neutral compound. So let's say for an example, let's say here to write the formula of the product AY. And let's say now that the charges on AY as follows. Let's say A is +1 and Y is -1. Then now to write the formula of this AY product, it simply be A1Y1 or AY. And now let's say for another example, let's say now write the formula of this product BX. And let's say the charges of Bx is B plus 2 and X is negative 1. Then now the form of this product right here would then be Bx2. That's how we produce a neutral ionic compound. And similarly, let's say we have Ay, and now the charge on Ay, A is positive 1 and Y is negative 2. Then now the form of this product right here will then be A2Y. Whatever A2Y would be, then that's what there will be 2A for every one Y. Whatever A and Y would be. And another example, let's say we have a Bx product where the charges on B would be plus 2 and X is negative 3. Then now the form of this product right here would then be 3X2. This is how we would have a neutral formula of the ionic compound. Okay, and so here's something very important right here. This is something that a common mistake that students make all the time. So as we are writing the formula of the product, predicting the formula of the product, do not write the formula product so that the chemical equation is balanced. Because students would look at the chemical equation and they try to come up with create a product to make sure the chemical equation is balanced. Please do not do that. As we are predicting and writing the formula of the products, make sure we focus on only writing the correct formula based on the charges, but not balancing the equation. If the equation is not balanced later, then we'll go back and we balance it later. But initially, as we write the formula of the product, we should do so based on the charges of the ions. Okay, let's now try a few examples right here. Predict the products of the following reaction. If there is a reaction, state the driving force and provide the name of that reaction. So now let's try the example number 1. So in this case right here, we have a solution of potassium chromate reacting with a solution of barium nitrate. So we take two solutions. These two solutions, we react them together. Will there be a reaction? And if there is a reaction, what will be the products? So now let's try this. So first, potassium chromate. So chromate is CrO4 with a charge of negative 2. So here in this case right here, then potassium chromate, a chemical formula is K2CrO4. And now this is an aqueous. So because this solution, so we're making aqueous solution of this substances. So we know this is an aqueous, and we make an aqueous solution out of it. And now barium nitrate, the chemical formula of barium nitrate is BaNO3 2. So it's important that you know how to still remember nomenclature and be able to write the formula of this reactants right here. So that's what we have right here. We have these two solution containing these two substances right here, and we are reacting them together. So how would we be able to predict what the product would be? So here's what happened right here. First, assume the reaction going to happen to see what the product would be, and write out the formula of the product, and then see if the product is meeting one of the three driving forces. So after we have the product draw its chemical formula written out already, see if it precipitates by using its solubility, and or see if it's a molecular compound or a gas. If one of the product meets one of those three requirements, then we know this reaction going to happen. So here in this case right here, let's now first assume the reaction going to take place. What will be the product first, and write the formula of the product. So here in this case right here, the easiest way to do this is as follows. First, we have potassium, and we know that potassium is positive 1, and chromate is negative 2. So basically, we are identifying our A and our X, our cations and our anion in the first ionic compound. And now we move to the second compound and do the same thing. Identify the cations and the anion and the charges. So here in this case, barium is the cations, and that is positive 2. And now nitrate is the anion, and the charge is negative 1. And again, only focus on the charges. Don't let the subscript bother us. Right now, there's a 2 right here. Ignore that for now. okay, but only focus on the charges. So here in this case right here, if the reaction going to happen, then the potassium, which is the cation from the first compound, would now be forming compound with the nitrate or the anion from the second compound, right? So if anything going to happen, potassium would now be forming compound with nitrate. So when potassium and nitrate come together to form a compound, what kind of compound would it be? And what would it be chemical formula? And here in this case again, please ignore this too. Do not focus on the subscript for now, but just focus on the charges. Because potassium is +1 and nitrate is -1. Therefore, the formula of this compound right here will then be KNO3. And there you go. That's how we know. That's how we write the formula for the first product. And now, as for the second product, barium, which is the cation, would now be forming compound with the chromate, right? And because barium is +2 and chromate is -2, they would come together in 1:1 ratio to produce a neutral compound. So therefore, a chemical formula would then be BaCrO4. So there we go. And now we want to use the solubility to figure out whether this would be meeting one of the driving forces. So here in this case right here, we have potassium nitrate, and we know potassium nitrate is soluble in water. So therefore, it would then be an aqueous. And as for barium chromate, barium +2 and chromate -2. And again, whenever we have +2 and -2 coming together, very likely that will be insoluble in water. So here in this case right here, this is insoluble in water and it is a solid. So what happened in this reaction is that we are seeing the formation of a solid, a precipitate, and that would then be the driving force of this reaction. So this reaction right here meets the precipitate driving force. So therefore, it will happen. Okay? And now this reaction right here would then be referred to as a precipitation reaction. RXN stands for reaction. So that would be the name of this reaction right here, and that would then be the product. And now, so again, this is how we write the form of this product right here. And now to the end, you may be tempted to say, hey, this chemical reaction right here is not balanced. I have 2 nitrate over here, and now on my right side, I have only 1 nitrate. To now make sure this chemical equation right here is correctly balanced, we now will go back and add the subscript 2 in front of the KNO3, and now our chemical reaction is balanced. And again, let me repeat this one more time. Do not be concerned with balancing the equation as you predict the form of the products. But as we write the form of the product, focus on the charges of the cations and anion and make sure if the overall chemical formula is neutral. And if anything is not balanced, we'll go back and balance it afterward. So balancing is the last step that we need to do. Okay. And now let's try another example in here. So example number 2, silver chloride precipitate. While here in this, when solution of sodium chloride and sodium nitrate are combined together. So in this example right here, we're kind of giving away the product already. Let's say that we're not even given this product right here. Let's say this data right here is not given. All we have will be solution of sodium chloride reacting with solution of silver nitrate. What will be the products if there is a reaction? And what will be the name of these types of reaction? So let's do that. So here in this case right here, our first reactant is sodium chloride. And the chemical form of sodium chloride will be NaCl. And now we have a solution of it. Therefore, this implies this is an aqueous. And now reactant with silver nitrate. And the chemical form of silver nitrate is AgNO3. And again, this is soluble in water, so it is an aqueous. So that's what we have right here. 2 compounds reacting with each other. How do we now predict the formula of the products? Okay, so again, we don't know if this reaction right here is going to happen until we predict the products produced first and see if one of the product meets the three driving forces. So here in this case, let's now predict the product first. So here in NaCl, the cation is sodium, and that is +1. And the anion is the chloride, and the charge is -1. And the sulfur is +1, and the nitrate is -1. So that's the trick right there. Identify your cations and your anion and the charges and put them right below. So that way we can now predict what's going to happen. Because sodium is the cation, if anything going to happen, it will now come in and form compound with the anion from the second compound. And that would be nitrate. And because sodium is +1, nitrate is -1, they will come together in a 1-to-1 ratio to produce a neutral substance. So in this case right here, we will be producing NaNO3. That will then be the formula of the first product. And now the other product is when we have sulfur come in to bind with the chloride. Because sulfur is +1 and chloride is -1, again they will come together in 1-to-1 ratio to produce AgCl. So this will be the products right here, assuming the reaction going to happen. But again, now, will there be a reaction or not? Then we have to be looking at both of this product right here to see if one of them will be meeting one of the driving forces that we need to have. So here in this case right here, sodium nitrate, this is soluble in water, so this is not a precipitate, but then this is soluble in water. And AgCl is actually insoluble in water. So there we have it. Now one of the product is meeting the driving force right here. So this is the driving force of this reaction. So a solid is being produced here in this reaction. So therefore we can also refer to this as a precipitate reaction. Okay? Or precipitation reaction. Let's now try the example 3. Solution of hydrochloric acid and solution of sodium hydroxide reactant. So now let's predict the products if there is a reaction. So here in this case right here, a hydrochloric acid solution, that would then be HCl, and it is an aqueous, reactant with sodium hydroxide, which is NaOH, aqueous. So those are the reactants right here. And now again, let's predict the form of the products. If the reaction going to take place, the hydrogen, so in HCl, the hydrogen is the cation, and the chloride is the anion. And in sodium hydroxide, the sodium is the cation, and the hydroxide is the anion. So if anything going to happen, hydrogen would now be forming compound with OH. And because H is +1, OH is -1, they will come together in 1-to-1 ratio. And that would then be producing water. And we know water is a liquid. And now the sodium would then be binding with the chloride to form NaCl. And now when we apply the solubility in, then we see sodium chloride is soluble in water, so it is an aqueous. So will there be a reaction here in this case? I don't see a solid being producing. So will there be a reaction? And the answer is yes, there is a reaction. Because here in this reaction here, the driving force is not a precipitate, but the driving force is the formation of a molecular compound. This product right here is water, and it consists of non-metal in them, hydrogen and oxygen. So therefore, this is our driving force of this reaction, and it is a molecular compound. So therefore, the name of this reaction right here will be a molecular compound formation reaction. So molecular compound formation reaction. And there will be a reaction here. And now let's go back and see if this reaction is balanced, and it seems that it is, so therefore we do not need to do anything else. And that's how we predict the product of this reaction right here. Let's now try another example. Solution of sulfuric acid reacting with potassium hydroxide. Will there be a reaction? And if there is, what will be the products? So please try this before looking at this answer together. So let's assume you have tried this already. Let's now go over this together. So sulfuric acid solution is H2SO4, and it is an aqueous solution. reacting with potassium hydroxide, which is KOH. And this is in aqueous solution as well. So what would then be the products? So here in this case, on the sulfuric acid, it's important for you to remember that acid have hydrogen, produce the proton or the hydrogen ion. So the hydrogen here would then be our cation, and hydrogen is +1. And the sulfate here is our anion, and this is -2. And the K here is our cation +1, and the hydroxide is then -1. So if anything going to happen, the hydroxide will then be forming compound with the hydrogen. And that will then produce H2O, or water. And we know water is a liquid. And now the potassium will be binding compound with the sulfate. Potassium is only +1, and sulfate is -2. So in order for them to form a neutral substance, then there have to be 2 potassium for every 1 sulfate. So therefore the chemical formula is K2SO4. And now when we apply the solubility guideline, this is soluble in water. So this is in aqueous. So there we go. This would be the formulas of the products. And when we analyze this reaction right here, we will then see that it is not correctly balanced. To balance this equation, we need to put 2 here and then 2 of the water. And there we have it. So this would then be the driving force of this reaction. So this is another molecular compound formation reaction. And now let's try the reaction number 5. When sulfuric acid reacts with lithium sulfide, dihydrogen sulfide gas is being produced. Okay, so let's see what happened in here in this case right here. So we are being told what will be the product being produced right here. But let's again assume that we don't know. Let's say this is not given to us. Let's see if we can still come up with this product right here. So sulfuric acid, H2SO4, and it is in aqueous, reacting with lithium sulfide. Lithium sulfide is Li2S. And this is soluble in water, so it is in aqueous as well. And now what would then be the formula of the product? Again, it's really easy. This is the same approach as we have been using throughout all of this example. Identify our cations and our anions and their charges. So here in this case, the cation would then be the hydrogen and that +1. The sulfate is -2. The lithium here is the cation and that is +1. The sulfide here is the -2. So anything going to happen, the hydrogen would now be binding with the sulfide. Because the hydrogen is +1 and the sulfide -2, there has to be 2 hydrogen for every 1 sulfide, right? So therefore, the chemical formula is H2S. And now, we are being told this is a gas right here. So this is both a molecular compound and a gas. And a molecular compound too. And the other product of this reaction is when we have lithium binding with sulfate. Because lithium is +1 and sulfate is -2. So therefore, to produce a neutral substance, there has to be 2 lithium for every 1 sulfate. Right? So therefore, Li2SO4. And when we apply the solubility rule, we know that this is then soluble in water. So therefore, it is in aqueous. So there we have it. And now here in this case right here, what will be the driving force of this reaction? And the answer is this reaction right here meets 2 driving forces. The first one is the gas formation, right? Because this product right here, as we've been told, it is a gas. And the other driving force of this reaction is also a molecular compound formation. Because H2S, as we've been told, is a molecular compound. So this reaction right here meets both of the driving forces. So therefore, it will happen. Okay. And now let's try the last example, example number 6. Hydrochloric acids reacts with sodium hydrogen carbonate. So let's predict the product of this reaction right here. So hydrochloric acid would then be HCl, and this is soluble in water, so it is an aqueous, and reacting with sodium hydrogen carbonate. Sodium hydrogen carbonate, NaHCO3, and this is soluble in water as well. So what will be the product of this reaction? And again, we will be using the same strategy that we've been using in all of this example right here, by identifying the cations and the anions and the charges. So here in this case right here, the hydrogen is +1 and the chloride is -1, and here the sodium is +1 and the rest of this hydrogen carbonate is then -1. So here in this case right here, the hydrogen will be binding with the hydrogen carbonate, and that will then form H2CO3, which is basically carbonic acid, right? And this is soluble in water, so it is an aqueous. And now sodium will be forming compound with the chloride, and that is producing NaCl, and this is soluble in water. So there we go. That will be the product of this reaction right here. But here's what happened right here. This product right here, carbonic acid. Carbonic acid is actually one of the substances that when it is being produced in the presence of water, it can actually further decompose into other substances. And carbonic acid has been known to actually decompose to produce CO2, gas, and water, liquid. So that's what happened right there. It is one of the products that we now refer to as an intermediate product. It gets produced, but it does not last very long. It will further decompose it to form all the gases. So in the end, this is what it would become. So therefore, rather than writing carbonic acid, aqueous carbonic acid, we're not going to write that, because in the end, it becomes CO2 and water. So therefore, the product that we need to write would then be CO2 and water. And the other product here would then be NaCl aqueous. So this would then be the final product of this reaction right here. So here in this case right here, we have gases being produced and we have water, liquid being produced. So again, it meets two of the requirement. So this, we can refer to this as a gas formation reaction, because it produces gas. Anytime the reaction produces gases, we call this the gas formation reaction. But we also see that a molecular substance is being produced as well. Okay, and now here's something very important right here that perhaps it's important for us to keep in mind as we perform this reaction in the lab later. Anytime a molecular compound is being produced, the reaction will also produce heat as well. So if we mix things together, and one of the observations that we observe is the reaction get heat up, then it tells us that one of the products is a molecular compound. So that's the kind of physical evidence that we should look for as we perform this reaction in the lab later. Okay, and here's something very important here to remember. Sometimes the intermediate product, such as the carbonic acid that we see above here, it is not a gas. In this case, a molecular compound, it is not a gas, but it can further decompose into a gas. And this is an acceptable gas formation that would drive the reaction forward. And sometimes, so here are some of the other intermediate products that we need students to recognize that once they are formed, they are not aqueous, but they can further decompose it into gases. Because sometimes when we look at this product right here, we see this is an aqueous, and this is an aqueous, and we'll be saying, hey, there's no driving force in here, right? There's no solid forming in here, right? But now we know that this will further decompose into a gas. And that's why it is an acceptable driving force. And here are some of the other intermediate products that can be further decomposed into gases in the presence of water. So carbonic acid, we have seen that already. If we were to have sulfurous acid, that would decompose to form SO2 and water. And if we were to have ammonium hydroxide produced, then it would decompose to form ammonia and water. So water is something common in all of this product right here. And again, these are the three products right here that we need you to remember in which they will further decompose to form this following gas above here. And it's actually quite easy. We don't actually have to remember this so much, because here's what happened. All of them will be producing water, right? So if I were to have H2CO3 and I'm taking H2O out of it, then the rest of this would then be CO2. So that's why that I can write this formula right here. And similarly, if I were to have H2SO3 and now I'm taking water, H2O out of this, what I would then have left would then be SO2, and that is the formula of the gas. And similarly with the ammonium hydroxide.